Welcome back to this channel for practice problems for actuarial exams. My name is Krzysztof Ostaszewski. You can find information about me at smartyurl.it/Jedi. My advice on how to pass actuarial exams is at smartyurl.it/pass. This video channel is at smartyurl.it/pass actuarial exams. Here you have information about online seminars and study manuals for exams PFM, IFM, and LTAM that I offer. I direct the Actuarial program at Illinois State University. You can find information about it at smartyurl.it/actuary. If you would like to offer a tax-deductible donation to support our students, please go to smartyurl.it/help ISU actuary. Here's the problem for today for exam MAS 1, Modern Actuarial Statistics 1 of the Casualty Actuarial Society. You are given the following information on the workers' compensation policy. Claims occur according to a Poisson process with rate lambda equal to 10 per week. Claims are classified independently into the following claim types. Claim type 1 with probability 0.2, claim type 2 with probability 0.3, claim type 3 with probability 0.5. For each claim, a random amount xi is added to a fund. The fund starts with an amount of 0 at time 0. The random variables xi follow the exponential distribution with the following means. Claim type 1, 500, claim type 2, 300, claim type 3, 200. Calculate the 95th percentile of the amount of the fund after 13 weeks using the normal approximation. There are 5 answer choices. Here they are. But we'll just calculate the amount and then we'll figure out which of these is appropriate. And here's the solution. This is a compound Poisson process, and the mean individual claim is E of x equals 0.2 times 500 plus 0.3 times 300 plus 0.5 times 200, and that's 100 plus 90 plus 100, so 290. Recall that the second moment of the exponential distribution is double the square of its mean, not the variance, the second moment. Therefore, the second moment is 0.2 times e of x1 squared plus 0.3 times e of x2 squared plus 0.5 times e of x3 squared, and that's 0.2 times 2 times 500 squared plus 0.3 times 2 times 300 squared plus 0.5 times 2 times 200 squared, and that ends up being 194,000. And then for the compound process with S denoting the amount of fund after 13 weeks, the mean is E of S equal to E of N times E of X, and that's 10 times 13, mean is 10 per week, so 10 times 13 over 13 weeks times 290, and that's 37,700. And the variance of the compound process is E of N times E of X squared, and we just calculated E of X squared, and E of N, as I pointed out to you, is 10 times 13, and that's of course N being the underlying Poisson process. So again, 10 per week and 13 weeks is going to give us the mean of 10 times 13. And this is equal to 25,220,000. For a large number of claims, S is a sum of 3 independent random variables, each of which is a sum of a large number of independent, identically distributed random variables. Thus, S can be, according to the central limit theorem, approximated by a normal random variable, and since xi's follow a continuous distribution, there is no continuity correction. Thus, S is approximately normal with mean 37,700 and variance 25,220,000, and S minus 37,700 divided by a square root of that 25,220,000 is approximately standard normal. Let us denote a standard normal random variable by Z if S 0.95 is the 95th percentile of S, then 0.95 is the probability that S is less than S 0.95, which is the same as probability that S minus its mean divided by its standard deviation is less than S.95 minus the mean divided by standard deviation. And because we are able to approximate the distribution of standardized S with standard normal random variable Z, this is approximately equal to the probability that Z is less than S.95 minus 37,700 divided by square root of 25,220,000. I am missing 1 0 in this guy here, am I? Right, I am. So I need to correct this. There's one more 0 here. With apologies. But I had that 0 over there. Well, that's too bad. I should have paid more attention. So again, with apologies, you can see that there are 4 zeros at the end here, and before in the other cases. This is now correct. Since the 95th percentile of the standard normal distribution is 1.645, we must have that this number here, that Z is less than, must be equal to that 95th percentile of a standard normal distribution, which is 1.645. So that S.95 is equal to 37,700 plus 1.645 times the, and again, there is not enough zeros there. So now corrected. It's 1.645 times the square root of 25,220,000. And that's approximately equal to 45,961.11, which is answer C. Please remember this is copyrighted material. The problem itself belongs to the Casualty Actuarial Society. The solution is mine. The problem is used with permission from the Casualty Actuarial Society. Good luck in your studies and good luck on the test.